Hey everybody. Today we're going to work through something called compound interest. So walking into today's class, you've now learned about the concept of simple interest. And today what we're going to work through is something that's a little more complex, but much more realistic. That really we're going to take the concept of simple interest and we're going to build it into the way the world works. And so really what you encounter most in your day is something called compound interest. So you'll see at the top of your screen on your handout page, we need to get down a little bit of information regarding compound interest. You'll notice what I've underlined in that first sentence. Compound interest is when the interest earned also earns interest. So the next sentence then, the total amount of an investment at the end of one period becomes the principal for the next. So all of that terminology we should be comfortable with from our simple interest discussion, but it doesn't mean that we really understand the concept of compound interest. So when we have underlined the interest earned also earns interest, really what that means for us is if I had an amount of principal, and I'm going to use my dollar sign to represent that amount of principal, and let's just say that it's sitting in a bank account. Well, if that money sits in that bank account over a period of time, then that bank account is going to have my original money, and then I'm going to put in pink a capital I, my interest. Well, with simple interest, we never calculate interest on top of our interest. But with compound interest, we do. Because what happens is my total amount in my bank account has now increased. You can see my dollar sign, my original principal, and now you see the other I, my interest. So during that next time period, I'm actually earning interest on my original dollar amount, as well as interest and more interest. And so what we would then say is my interest is going to compound because I am earning interest on my interest. And what you see on the bottom of your page, that's the big idea for today. We are going to start earning interest on our interest. Unfortunately, that also means that we might be paying interest on top of our interest. We'll see how that works out in practice. So to jump in then, let's work through some basic calculations for us, going through and calculating interest. So that's us using simple interest. We're going to calculate interest, and we're going to complete that table that you see on your screen. So you'll notice in year one, we have $4,000. We are earning 5% interest per annum. We should be good to be able to calculate that interest and then calculate the amount of the investment. So I think this is a good opportunity for us to pause for a second and you work through completing row one. That is going to give you feedback. Are you comfortable with being able to go through and determine simple interest? Okay, give it a shot on your own. Pause the video now. Okay, we're back. So for us making our calculation, we know that our interest calculation is our principal times our interest rate times our time. And I'm going to actually write the 1 in there so we can see it, like visibly see it, that it was a 1-year investment. So if we go through and we push some buttons and we calculate that interest, we should have found that that got us an interest of $200. And if our principal was $4,000 and we just earned $200, then that gives us a total amount of $4,200. So you use that top row as a check. How well did we do? Okay, where this changes now is that my starting amount for the next year becomes $4,200. Because over the course of the next year, I'm going to earn interest on the $4,000 that's in there, but also on the additional $200 that just got put in there because of interest. Okay, I think we have an opportunity to actually finish off the rest of the chart. So if you were feeling comfortable, then I want you to go ahead and pause it, and I want you to try to fill it all the way in until the end of year 5. If we're a little hesitant, then I want you to pause it and just try to complete row 2, and then we'll come back and we'll check and we'll see how well we're doing. Okay? Pause the video now. Okay, we're back. So hopefully our calculation then was now $4,200 times our interest, and again for 1 year. We now make that calculation, and we should have found that we got an interest of a little more. Now, it shouldn't be surprising to us that our interest was a little more because we were earning interest on top of our interest. So we earned the 5% interest on the original $4,000. That worked out to be $200. And now we earned the extra 5% interest on the extra $200. So again, and I'm killing this point, we earned our interest on top of our interest. That's going to leave us with a final amount at the end of year 2 of $4,410. Okay, if we were a little tentative and unsure about row 2, that was your opportunity to confirm some things, and now we should absolutely be good. Go start to finish off the last 3 rows, and we'll come back and we'll check and see how well we did. Okay, pause it now. Okay, we're back, and we are going to go really, really fast. That's going to be my $4,410, earning my interest for the next year. When I calculate that amount, I'm going to get a dollars and cents amount now. So I'm going to get $220.50. So if I take that and add it back on to my original principal, that is going to give me $4,630.50. That becomes my starting amount for the next year, and that's what I am calculating my interest on. So now my $4,630.50 is going to earn 5% for a year. That is going to get us to a rounded amount. We are going to earn exactly $231.52.5. We cannot earn a half of a cent. So that 5 is going to bump up that 2, and we now have 53 cents of earned interest. So we take that $231.53 and we add it back on to my principal at the beginning of that year, and that is going to give me $4,862.03. That becomes the starting principal for the next year. That becomes the amount that I am going to calculate interest on. So my interest, and we should be really automatic with this at this point, is going to now give me a value of $243.10 rounded. And so if I take that amount and I add it back on to my original, then we are going to finish off with an ending balance year 5 of $5,105.13. So that should give us something just to be able to work through. What I'm hoping when we look at that table is we can see the effect of compound interest. That as we earn interest on our interest, the amount of our investment is going to increase faster. We can see our simple interest calculations in purple, and then we can see how we apply that to a compound interest problem. Now, big picture, we are not always going to be compounding per year. For most of you, in your bank account, if you have a savings account at a bank, you're likely going to be paid interest semi-annually. So 2 times per year. That would require us to compound our interest more often. We would have to pay that interest into the account every 6 months, twice a year. Hopefully you guys can see that that would make your bank balance grow even faster because we would now get extra interest and we would have it earlier so we could compound more. For our class this year, you are only responsible for compounding our interest annually. In future years, you guys are sitting in a grade 11 math class, we start to compound it for a bunch of different time periods. For us right now, all we need to worry about is what you see in blue on the bottom of your screen. We will always be compounded annually. So let's work through an example now so we can kind of see how this plays out and just get a little bit better representation of how much extra this helps us. Okay, let's work through an example. What you see at the bottom of your page is 2 circumstances that we're going to compare. Problem A wants you to deal with simple interest being earned on $10,000 that's being invested at 4% per annum for 5 years. Problem B, we're going to earn compound interest. If that same amount of money, $10,000, was invested for the same amount of interest rate, 4% per annum, compounded annually for the same amount of time. So what is the effect on being able to go through and deal with that? Okay, you'll notice what I put down on my page. I kind of broke them apart. The purple, I'm going to figure out my simple. The pink, I'm going to figure out my compound. So everybody should be good to be able to go through and determine your simple interest. Okay, pause it now. Okay, we're back. So we know that our I equals PRT, and so our interest is going to equal our principal times our interest rate times the amount of time. And so if I go through and I calculate my 10,000, multiply that by my 0.04, multiply that by the 5 years that I will be earning interest, I am going to get $2,000 interest. What that means is at the end of that time, therefore, my amount is going to equal $12,000. My $10,000 at the original, my principal, plus my interest. Okay, now what we want to do is we want to compare our compound. So I'm just going to slide my title over a little bit here, make a little bit extra room, and we're going to determine our compound. Our compound is going to take a little bit more work because what you're going to notice is I need to be adding in that interest at the end of every year. Okay. I need to calculate simple interest every single year. So what about year 1? Well, then I'm going to have my 10,000 times my interest rate times my 1 year, because I'm only determining my interest for that 1 year. And so if I take my 0.04 and I multiply that by my 10,000, you're going to find that I get $400 interest in that first year. Well, my new balance at the start of year 2 is now going to be $10,400. My original principal plus my interest. Now that $10,400 is going to sit in that investment, think about it as a bank account if you want, for year 2. And if I take that amount and now I multiply it by 4%, then I'm going to earn interest of $416 in the second year. You'll already notice I'm earning more interest with my compound. Okay, that makes my year 3 balance. Now, $10,816. My $10,400 plus my interest. We are now going to multiply that by 0.04 for the year. So if I keep going on in this process and I calculate all that interest, yes, I'm going to start to get some uglier numbers, but I am now progressing through. I can now figure out my year 4 starting balance. That's going to get me to $11,248.64. And that's going to earn interest. And so when we multiply that by 0.04, I'm going to earn $449.95. Nice. If I take that $449.95 and I add that back on to my original balance at the beginning of the year, then I am starting year 5 with $11,698.59. Notice I'm already getting pretty close to that $12,000. If I work through my final year, year 5, and I figure out how much interest I would earn that year, I'm going to earn another $467.94. So, what does that make my final amount? If we are looking to compare those two amounts, then I need to take my $11,698.59, add on my final year's interest, and we are going to come in at $12,166.53. You will notice that if we compare those two amounts, I am earning an extra $166.53 by having my interest be compounded. So there is us going through that 2-step process. Find some simple, find some compound. We can look and we can compare the two just to have a sense of it. Now, you may be sitting there going, oh, yikes. Like, for every one of these problems, I have to do this big chart to calculate my compound interest? No. However, there is a shortcut for us to be able to get there. But for us to understand that shortcut, I think it's helpful for us to see the way we compound every single year. So what I want to do is I want to take that pink chart, in essence, and I want to break that down and almost go backwards. Let's take the pink chart and we're going to create a formula for it. So let's turn over the page and we're going to take a look at our new formula. What you see at the top of the page, I would like you to get down. And I'd like you to get that down in that big space provided. Our formula for compound interest is a formula that I will expect you to know. And it is A equals P times 1 plus I all to the exponent n. Okay, we need to break down the components of that formula. A is going to represent what we call your total amount. That is the total amount of the investment. P represents our principal. We're comfortable with that. I represents the interest rate. Now you may be looking at it going, hey, but why didn't we use R to represent that? Remember that all we are responsible for in this course is our interest rate being compounded annually. In future courses, maybe our interest rate gets compounded semi-annually, like your bank account. Maybe it gets compounded monthly, like a credit card. Maybe it gets compounded daily. Yikes, that's a lot of interest. The reason why we use I is because I actually is an adjusted interest rate. For us in our course, we will call it the interest rate per annum because we are only looking at compounded annually. What does that make n then? N is our number of compounds. So how many times will I earn that interest? How many times will my interest be compounded? There is your formula. I expect you to know it. And we're going to get really good at using it. My suggestion, anytime you need to learn a formula, write it down every time you use it. It's going to help it to drill in. Okay, let's jump through and let's play around with the two problems at the bottom of your page. Okay, let's take a look at problem 3. 3 says, if $800 is invested for 5 years at 10% per year, compounded annually, then we would like to find the total amount of the investment and the amount of interest that we earned. Okay, let's do this one together. We'll take our time, we'll map it through, and we should be good. So let's work through problem A. Problem A asked me to find the total amount of the investment. And lucky for me, I have a formula that allows me to deal with compounded interest that allows me to find the amount. My formula is my amount is my principal times 1 plus I to the exponent n. There's my formula. Let's plug in all of our information. Okay, I'm looking for my amount, so I'm looking to solve for A. That means I need to know my P. Well, my P was 800. That's how much I started with. My interest rate is 10%, so 0.1. My number of compounds. It tells me that it's compounded annually for 5 years. That means my number of compounds is 5. Okay, what do you guys need to show me? You can take that red line right now and you can punch it all into your calculator. My suggestion to you, though, don't type it in left to right. You're trusting your calculator too much. Trust yourself. Follow BEDMAS. Okay, I want you to take your calculator and we're going to punch all of that into our calculator. You're going to follow along with me. BEDMAS would say, let's do the adding first. So we're going to punch into our calculator 1 plus 0.1. Then hit equals. Leave that number on your calculator screen. The next thing we're going to do is the exponent. So now hit your exponent button. Remember, that exponent button might look like the little hat. Your exponent button on your calculator might look like x to the exponent y or y to the exponent x. You find your exponent button and hit that button and then enter 5. Hit equals. Keep that ugly number on your screen. And now we're going to deal with the times by 800. So now hit your multiplication, type in your 800, hit equals, and we should have our final answer. If we follow that and you trust your BEDMAS, then you don't have to trust your calculator. That's going to make you better at working through the process. It really will. As a little confirmation, that should get us to approximately 1,288.41. And we could then go through. When you take a look at problem B, we could now work our way through to determine the amount of interest earned. I would not need to see 1,288.41 subtract our original amount, 800. You would be totally fine to just tell me that there would be $488.41 of interest. So now let's just work through one more example to make sure that we are good to be able to go through and find the total amount of an investment and the amount of interest earned. You see question 4 on your screen. I want you to work through that, and we should be able to use question 4A and B as a check for our understanding. Okay, pause the video now. We'll come back and we'll confirm it. Okay, we're back. So for problem A, I need to find the amount, and I'm dealing with compound interest, so that's A equals P times 1 plus I to the n. I can plug in all my details. I had $1,200. I am investing that at 8% interest, and I'm compounding it annually for 3 years, so I have 3 compounds. Now I'm going to push some buttons. I am going to end up rounding. I'm going to put my units on. So I follow BEDMAS. I take my 1 plus 0.08 equals. I hit my exponent button, 3 equals. I now multiply by 1,200 equals. And that is going to give me $1,511.65. So if we came in at that, we're doing pretty good at being able to calculate compound interest. Question B now said, find the amount of interest earned. Well, again, I don't have to see taking your new amount and subtracting your old amount or your original principal. We do that, and you guys should be able to come in on $311.65. Nice. Okay, your job is to jump in and play through some of those examples and get very comfortable finding the total amount using compound interest and finding the amount of interest earned. Okay, jump in and get some practice. Good luck.